All right, so 6.3 is kind of like what we've been talking about lately, but it's kind of flip-flopped. So basically, let me tell you this. Everything we've said right now, we said if, let's everybody pay attention, we've started. So basically what we've done up to this point, especially in section 6.2, we were told that we had a parallelogram. Would you agree? All these homework problems, they said, this is a parallelogram, right? So all these said, if it's a parallelogram, then a bunch of stuff was true, right? For instance, what was the first theorem about parallelograms? What do we say about the opposite sides? Yeah, they're equal. They're congruent or they're equal to each other. So then I'm just shortening this a little bit. Then the opposite sides are what? Equal or congruent. All right, so we said if it's a parallelogram, then the opposite sides are congruent. Everybody understand that? All right, so we started off knowing what? That it was a parallelogram, okay? Today's lesson, we're going to flip the if and the then, all right? So today we're going to say, and this is actually the very first theorem, okay? So you can write this down if you want. So we're going to say if, it has a bunch of stuff before the if. It says if a quadrilateral, I wrote it a little different. I'm trying to rethink so I can put it in the if form. If both pairs of opposite sides of a quadrilateral, okay? Now, just a quadrilateral just means it's a four-sided figure, correct? So, if the opposite sides, I'll just put just in our head, just think of a quadrilateral, okay? So if the opposite sides of a quadrilateral are what? Equal to each other or congruent to each other, then what must be true about that quadrilateral? What must be true about it? It must be a what? A square. When do we say square? What is this thing? It must be a parallelogram. So we flip the if and the then, all right? So if the opposite sides of a quadrilateral, okay? If the opposite sides of a quadrilateral, not parallelogram, okay? Don't know it's a parallelogram to begin with. But if the opposite sides of a four-sided figure are equal to each other, then that four-sided figure, that quadrilateral, must be a what? Then it's a parallelogram, okay? You see the difference? Right? Yesterday we learned if it was a parallelogram, then a whole bunch of stuff was true. Opposite sides are equal, opposite angles are equal, all that kind of thing, okay? But today it says if you got a four-sided figure, you're looking at it, you're like, I don't really know if that's a parallelogram or not, but you saw that the opposite sides were equal to each other, then what could you determine about that thing? That it's a parallelogram. So let me show you. So I'm going to make this look like our normal everyday parallelogram. All right. But right now, I don't know anything about this. If that's all you saw, could you tell 100% that that's a parallelogram? No, because they didn't tell you anything about it, right? I don't know anything about it. I just know I got four sides. I just know it's a what? Quadrilateral. That's all I know. But watch this. What if they told you that this side was equal to this side and this side was equal to this side? Now you can say what? That it's a parallelogram because of our theorem. The theorem says if you have a quadrilateral and the opposite sides are equal to each other, guess what this thing is now? It's a quadrilateral. Or it's a parallelogram. Okay? Do you see the difference between yesterday and today? Okay, yesterday we would have said what? If it's a parallelogram, if they told you it was a parallelogram, then what's true about the opposite sides? Then they're equal. Today we're saying, all right, here's just a four-sided figure. We don't know anything about it except that this and this are equal, this and this are equal. So now what can I say about it now? Now I know it's a parallelogram. Okay? You see the difference? All right. So that's kind of what we're going to be doing. All right, let's do another one. Let's just, I'll tell you what, let's use the same picture and I'll just write some stuff in here. Let's just use a different color, change that up a little bit. Come on. I got to push extra hard to get that. I don't know why. All right, here we go. What if right now, sitting there right now, okay, is that a parallelogram? No, we don't know it is, okay? So, but what if I told you that this and this are equal? Now, is it a parallelogram? Not yet. No. Not just one pair of opposite, what? Both pairs of opposite angles have to be what? Equal. So, if I knew this, if that's all the information I know, don't know anything about the sides, I just know this information right there. Can I now say that this is a parallelogram? Absolutely. Okay. So if the opposite angles are equal to each other, then what is it? It's a parallelogram. Getting the idea? All right. Let's do another thing. Remember we did this? Remember that? Diagonals? Right now, do I know it's a parallelogram? No. But what if I knew? What do you think I'm going to do here to this? What do you think I'm going to show you on these diagonals in order to make it a parallelogram? They do what? Yeah, let's say that's a better way to say it. They bisect each other. Let's just not say they're in the middle. Let's say they bisect each other. So if I told you that those two yellow lines right there bisect each other, which means that and that would equal each other, and this one would equal each other. If that's true, if those diagonals bisect each other, what kind of figure do you think that is? It's a parallelogram. Exactly. You with me? Okay. I'm going to show you one more thing. This is actually the second thing they showed you in the book. I left it to last because it's a little bit different. So every one of these has been basically the flip-flop, right, of the theorems that we've already learned. Do you agree? All right. We call that a converse. A lot of geometry teachers teach you this kind of stuff, and maybe it's in this book. I think it is. I think it's probably in some of this stuff's in chapter 2, which we skipped. But the if and the then, right? So if you have if something, and then you have then something, right? A lot of times they write it like this. They write P, an arrow, then Q, all right? I'd hate to go through a whole geometry class and not even mention this. So this is all this is. This is just a mention. It's not going to be on a quiz or a test or anything, all right? It's just so that you can see it. Because sometimes I feel bad about skipping things, but I know I have to skip some things because we'll just never get as far as I want to get, okay, if we don't skip some things. So I decided to skip this chapter. So the if part is the P, the then part is the Q. Everybody see that? So P represents if blah, blah, blah. The Q represents what? Then blah, blah, blah. All right? So what do you think the things that we're doing today, instead of if then, what did we do first now, today? Q, then P. That's right. So today we're going Q, if Q, then P. You follow me? These are called converses. When we switch the order of these, they call that the converse of the if-then statement, I guess, okay, of the statements. I just thought I'd throw that in there because it's something that, there's whole entire courses that are just this kind of stuff with this P, then Q. They have all these things with truth tables and it just goes on and on and on. I took a geometry class in college, and most of that geometry class was basically that kind of stuff. All right, so you can just see that it is taught a lot. We're just not doing it in here. But I just wanted to throw that out at you since we're doing a lot of if-then statements, okay? This one is not a converse of one that we learned earlier, though, okay? So that's why I saved this one to last. This one, do you remember what the definition of a parallelogram was? Before we said anything about the opposite sides being equal, the opposite angles being equal, and all that stuff, what's the first thing that we learned about a parallelogram? How do we know it's a parallelogram? By the definition. Exactly right. The opposite sides would be parallel. That's what I wanted to hear. All right, so this is by definition. All right, the opposite sides would be parallel. But let's say I didn't know that this side and this side right here were parallel to each other. But I did know something else. I did know that those same two sides that are parallel, that I know are parallel, somebody told me that they were equal to each other. This is enough to say that this thing is a what? Parallelogram. So the theorem basically says this. If one pair of opposite sides, would you agree? This is just this side and this side. That's one pair, right, of opposite sides, are both parallel and equal to each other, then what's that figure? It's a parallelogram, okay? So this is not really a converse of something that we learned the last day or two, right? This is kind of on its own, I guess, right? So if this side and this side are both parallel to each other, and I don't know anything about the other two opposite sides. I know nothing about the other two opposite sides. I just know something about these two opposite sides, but I know two things. I know they're parallel, and I know they're equal to each other. That's enough to say that whole thing is a parallelogram. Everybody with me on that? So if that's the only thing I told you, and I said that that was 5, tell me what this side right here is. It's going to be 5. Because if it's a parallelogram, which we know because of this and this, then these two have to be opposite. These two opposite sides have to be equal to each other as well, don't they? Okay? So there you go. Let's do some examples. How about that? I'll tell you what. What do I got? 5 minutes. 5 minutes. So let me make this a little bit smaller. And I'm going to bring this in a little bit. And I'm going to twist it like that. Yeah, that looks like in the book. Just trying to make it look like what it looks like in the book. All right, so this is D, E, F, G. You know what? I only got 5 minutes, right? So I'm going to skip that one. That's example 1. You can look at example 1 yourself in the book. All right? I want to skip to this one because this one's... Example 1's just kind of leading you up to example 2. That's all it is. So it's not that difficult. It pretty much rehashes what I've been talking about. This one, we're going to have to do just a tiny little bit of algebra with it. So I think this will be a better one if I had to pick between the two. That's P and this is S. And this is T. All right, here we go. Let's write some stuff down in here. So this is 5A. This is 20. This is 6B plus 2. Now this one's easier than the one we did when we went over the homework at the beginning of class. It's considerably easier. All right. Now, here's what the question is. Now, this is a little different. It looks like, let me just teach this. I only got a couple minutes. It looks like what you did on the last homework, doesn't it? All right. But the thing is, they don't tell you that this is a parallelogram. The question says this. It says, find the value for each variable that ensures that this quadrilateral is a parallelogram. What does that mean? That means tell me what A should equal and tell me what B should equal in order to make this quadrilateral into a parallelogram. You follow me on that? So what do we know when we have diagonals? Well, we know if a quadrilateral's got 2 diagonals, if those diagonals are being bisected, then this thing is a what? Parallelogram. So the math is pretty much the same as what we did. It's just they changed the wording of the problem, right? It's almost identical to what you've been doing, except they don't tell you it's a parallelogram. We got to figure out what A and B is in order to make it a parallelogram. Okay? So you basically do the same thing. Your math is exactly the same. So what's true about this 5A and anything else in here? It's equal to 20, right? So 5A is equal to 20. Look at this. This is a lot easier than the problem we did earlier in class because I only got one variable, don't I? So what's A in your head? What's A? It's 4. All right, so that's easy. Let's find B. What do I do? What do I do with these? Set them equal to each other. Exactly right. I'm going to put the 7 first. I like to put the bigger one on the left-hand side because it doesn't matter, does it? 6B plus 2. Let's do it in our head. Subtract 6B from both sides, we get B. Add a 4 to both sides, we get 6. It's easy, right? So there's A and B, and that's all they want you to find. It says find the value for the variables that makes this a parallelogram. So if A is equal to 4 and B is equal to 6, that makes this thing into a parallelogram. We good? Let's do one more. I subtracted 6B, which is a 1B, and I added a 4 to this. and I got a 6. All right, let's do one more. I think we got time. We still got like 2 minutes left. I can do this pretty quick. So it's basically the same thing, except you're not dealing with diagonals this time. All right, you're just dealing with opposite sides. Now, I may not have time to finish the whole problem, but if you notice this is where we're going to do what? What's that word I used a bunch at the beginning of class when we went over that homework? Substitution. That's right. Let me push this over a little bit so I have room to work. I'll set it up for you, then I'll let you work it out, okay? So we don't know that this is a parallelogram. They don't tell you it's a parallelogram. What we want to do is find what? X and Y, find the number for X and find the number for Y that's going to make this thing into a parallelogram. So how would you do that? What would you know? What do you know about the opposite sides in order to make it a parallelogram? They must be what? Equal to each other. So what are we going to do? Yeah. I'll tell you what, I'm going to put Y plus 14. I'll do that for a reason. Actually, it doesn't matter. Let's do the 2x. You're right. Let's do that. Let's go 2x equals Y plus 14. And what else? Yeah. Now, this time I will put the Y first. Just to make it a little easier. It doesn't matter, to tell you the truth, one way or the other. All right? So I've set it up for you. I got a minute. Let's do it. So I kind of know what Y is, right? So what am I going to do with that? Plug it in for the other Y. Yes? All right. Is this getting a little easier for you now, this substitution thing? Yeah, it should be. So I just rewrite that first equation. What's it going to be? 2x equals, what's Y? X plus 11. Finish off the rest of the equation. Plus 14. And then you solve for it. Let's do it in our head. Subtract an x. What do you get? X. 1x. Not just a 1, but a 1x. Then add those up. What's that? 25. Okay, let's solve for y. Y is just what? 25 plus 11, which is 36. And there's your answer. Okay? So that is section 6.3. 18 to 25. Okay? So 6.3, 18 to 25. Section 6.3. You can find the page numbers. Just go to section 6.3 and do 18 to 25. Okay?